Everyone, good afternoon. Thank you for joining our Cognitive Systems Institute speaker series. Today I'm happy to introduce Sue Feldman, who is a technology industry analyst and entrepreneur. Sue developed and directed IDC's coverage of the search and text analytics market for 12 years before founding Synthexis, her consulting business. She's co-founder and managing director of the Cognitive Computing Consortium and is the author of numerous articles and books. She holds degrees from Cornell and University of Michigan in linguistics and information science. I am happy to turn the call over to Sue, who will be presenting a framework for understanding cognitive applications. Thanks, Sue.
Thanks, Diane. So I'm a technology analyst, and my job is to listen very hard, to learn as much as I can, and then to translate what I understand about technologies into something which tells people who are buyers or users of technologies what it is and why they should care about it. I don't develop technologies myself. I do test them occasionally, but that's not the purpose of what we do. So just a quick word about the Cognitive Computing Consortium. We started in 2014 with a group of people who were industry and academic experts in the emerging field of cognitive computing. We are independent and try to make sense of this emerging area, which is, we believe, an extraordinary leap forward in computing. Our research started by defining what cognitive computing was. We convened a working group in 2014. We argued for months, and I'll show you what we came up with. But the purpose of my presentation today is the second bullet, this framework that we've been working on for making cognitive applications understandable to potential buyers and users. And that meant that we needed to identify which problems were amenable to cognitive computing and identify what types of cognitive applications were emerging, and finally try to compare cognitive approaches to other computing systems which are more traditional. Our next areas of research will be to develop a trust index to track market acceptance of the believability of these systems and their recommendations. And we are in the process of publishing guides for practitioners and frameworks for discussion. We have a monthly column in KM World, which reaches about 45,000 people. And again, what we're doing is trying to make cognitive computing understandable and essentially desirable for people who have the right kinds of issues that they need to resolve with a different kind of system. So this is what I am going to talk about today, the definition and then the framework. And what I'm looking for specifically, because this is early days yet in terms of the framework, is your feedback. And I'm hoping that we will engage in a continuing dialogue about this. I mentioned that working group. In 2014, after all of our arguments, we ended up with 5 elements that we feel are necessary for a computing system or application to be considered cognitive. The first is that it learns and adapts. It reacts and changes based on new information, on interactions, on new goals from the users. It is probabilistic, not deterministic in nature. It is contextual. In other words, it uses its context, which may be an individual or a problem or group or goal, to filter the results depending on the who, what, where, when, why of the user or users. It's conversational, and this is important. At some level, it understands human communications. You can call it meaning-based, and of course there are various other communications it needs to make sense of. It's interactive, it's iterative, And it's stateful, so it understands where you are, what your history is in a particular task, and where you may be going with it. It's also highly integrated, and that means both the data and the technology, because you're looking at data from multiple sources that may use different terminology, sometimes different languages, and merging those sources is one of the great barriers or hurdles in putting together a cognitive system. The technology, however, is also integrated in that, for instance, the output of one categorizer may influence the ranking of the confidence scoring system. So the next thing we did was to try to define what kinds of problems were amenable to cognitive computing. And in general, we believe that these problems are more complex and deal with more ambiguous situations than we are accustomed to attack with traditional computing. The information and the situation may shift, and the outcome, as I said before, depends on the context. There may be diverse and changing data sources, including unstructured, in particular, text or images. There are no clearly right answers or no clearly one single answer. The data tends to be complex and ambiguous, and sometimes there's conflicting evidence. It's presented typically as being confidence scored or ranked. Multiple answers are preferred, so that the user is looking for not just that single answer, but perhaps to explore alternatives as well. It is process intensive, and the process may be difficult to automate because of the unpredictability of the shifting information or the changing users. It tends to be context dependent, and exploration is a priority across silos, again, that requires that data integration. And finally, we believe that it requires a human-computer partnership, which is only beginning to emerge. And in fact, MIT is doing some interesting work on this right now. But the fact that there's some sort of dialogue on some level required is certainly a different kind of approach to how we integrate computers into our workflow. So if we go to the next slide, there are also certainly significantly different times that you do not want to use cognitive computing. In particular, you do not want to use cognitive computing when you're looking for predictable, repeatable results. You're looking for surprises. You're looking for unknowns as well as knowns. And if what you want is to churn out monthly sales reports, it would be pretty upsetting to have them presented differently every month. Also, if all the data is structured, perhaps what you're looking for is an Internet of Things kind of approach rather than cognitive computing. If you don't need interaction or when you do not want a probabilistic approach, obviously cognitive computing is not for you. And sometimes in the cases of regulatory industries, you have to be a little bit careful because you do need to be able to defend your results or your actions. And of course, if you're pretty happy with what your current systems are doing, why would you change? Because change, of course, requires a great deal of effort and is unpredictable in itself. Now, the other thing we looked at was what's happening, the ferment that's going on in the IT industry today. And you see, even in the popular press, a lot of talk about Internet of Things, certainly artificial intelligence, conversational systems, search, text analytics, cognitive studies, BI, data analytics. All of these things are talked about and contribute to cognitive computing, but cognitive computing takes elements like machine learning, for instance, or text analytics, or speech recognition or visualizations from each of these and turns them into something that is quite different. And, of course, we can have an interesting discussion about those differences, but not today. So let's move on to the work that we've been doing, which is to come up with some ways of looking at cognitive applications and how to design or think about them for people who are considering adopting them. The first thing we came up with was this sort of pseudo equation in which we've sat down and brainstormed the various parameters, variables, ingredients, if you will, that might go into an application. They seem to fall easily into these four categories: the data, of course, the technologies, but also the design of the output, the behaviors that you would expect out of that system. And finally, the goal. What is it that you hope to get by using cognitive computing? Now, this may seem obvious, but many people just go out shopping for software without in any way really pinning down why it is that they're looking or what they hope to get out of it. So what we tell our clients is you have to start with a goal. I know that sounds silly, but it's pretty much like somebody going out and buying a car without first figuring out what it was that he was going to use it for. And in that case, he might come home with a really cool, shiny red sports car when what he needed was a family van. That's kind of a crude example, but in fact that goes on a lot. And then you get people writing about why does search stink, which was, you know, a great topic of conversation in the last decade. Well, mainly search stinks because you went and bought something that doesn't work. Sentiment extraction is another example in which people are buying things or were buying things that were just not suitable for the specificity with which they needed to analyze text. So here's an example of how you might use this framework for thinking about how an application is put together and what it does and what it needs. So this one has been in the press a great deal. It's an oncology treatment advisor. The value is extreme in that it gives you better decisions and saves lives. And, well, how are you going to do that? What you need to do is design a conversation or dialogue that asks questions of the physician and the patient, perhaps, returns recommendations, and that is iterative in nature. It returns high confidence recommendations. It doesn't return, 100 of them, maybe the top 3. And in order to do this, there are a long list of technologies that are required, and the underlying data is carefully structured, curated. The domain knowledge is deep and takes a fair amount of time to develop. So that is one kind of application. But we wanted to go further because this is just looking at each application by itself, and what we needed was a way of looking at a spectrum of applications. So we started thinking about what we knew already from the search and text analytics market, and that is that there is a continuum of software applications, and particularly in the areas I know the best, you have this tension between designing for accuracy and designing for serendipity, and both have enormous value. Again, back to you need to buy what it is that you're going to require in order to get the output that you need. So if we look at both ends of the spectrum, we see something I'm calling expert systems. at the left side, and discovery and exploration applications on the right side. Expert systems, I know the term has a lot of baggage, but we couldn't come up with anything that really reflected what it was that we were seeing. So imagine this is an expert system the way it had been envisioned 2 decades ago and finally is coming into its own. These systems deliver answers for an individual. The individual is the context. They are tuned for high accuracy. They have a great deal of domain-specific, carefully curated information. It takes quite a while to build them because of the ontologies, the normalization. The process tends to be, at this point, manually intensive. They may have rule bases, heuristics, and the input is perhaps an expanded question, if you will. And, of course, there are problems. There always are with trade-offs that you have to make in designing systems. Overfitting, misrelated information, changes in terminology, too little information. These are just some of the problems. On the other end of the spectrum is the discovery and exploration application, which is tuned highly for serendipity. Here's that trade-off again. And therefore, probably low confidence, because what you want to do is to eliminate built-in expectations about what the information patterns are. You're looking for patterns, you're looking for anomalies, clusters, and what you want returned to is an information space for further exploration. There may be some general knowledge built into it. The prep time is probably lower. The problem is specified as a goal or process, and that becomes the context by which you are constraining the system in some way. You don't necessarily need to curate the data. In fact, you may not want to because, again, you want to find surprises. So, of course, social media data comes to mind, but equally, perhaps collections of email from a large company which need to be examined as an information space to find patterns of fraud. And there may be some grammars and vocabularies, etc. Of course, in this kind of system, you always have problems of confusing correlation and causation. Low accuracy may be annoying. You probably have more false drops and false leads, and you may have so much information that you are overwhelmed, which is why visualization is so very important. And being able to visualize the same information in multiple ways may be also important. So drug discovery, as in the case of that Baylor University example, which found in a matter of weeks 12 years worth of research on a particular kind of cancer drug, would be something that would be amenable to the high serendipity end of the spectrum. So that was a beginning. But we wanted to be able to classify emerging applications as they appeared a little bit more subtly. And for that reason, what we decided to do was to examine other ways of visualizing this kind of continuum. What you see in this is a 4-box presentation in which we've got modality, in other words, that expert system in discovery and exploration, on the left, and on the top are the 2 different kinds of context which are used to filter the information. So just to point out where we are here, that expert system which is tuned for the individual is on the lower left, high confidence, low serendipity. And the other end of the spectrum is on the upper right, high serendipity, low confidence. We've looked at those already. But there are degrees in between. and possibly we will end up having to expand this even further. For now, though, if you get lower confidence, I'm sorry, that says low confidence, and it's not, it's mid, and mid serendipity, but within the context of the individual, and I realize I'm going awfully fast over this, so we can discuss it. But in other words, a degree of less accuracy and more exploration, but still for a particular individual, that would be that upper left box, and your lower right box is, again, mid-confidence and serendipity, but within the context of a task or a process or a goal or a problem. And the other thing that you'll see is this arrow on the bottom, because we feel that, as you explore information on the right, you may end up with data sets which are extremely valuable for contributing to knowledge on the left, and vice versa. So there's a flow among all of these, no question about it. So let me just show you a few examples of these, and then I'm going to stop and ask for questions. As you see, the oncology advisor or an investment advisor or shopping recommendations that are made within the context of a particular individual's profile or preferences is your lower left expert system. But if you relax the accuracy and increase the serendipity on the upper left, you'll find possibly the cognitive assistance for the blind, which is so complex I'm not even going to try to go through that right now, but that may actually appear in all four boxes because it is a complex system. But think about staffing recommendations in which you're looking for an individual who will fit both psychologically and by means of expertise a particular project that you need to staff. You're going to relax the constraints. You're going to want a degree of serendipity in looking through all 100,000 of your employees, but you're looking for an individual still. And then on the right, as I mentioned, drug discovery on the upper right, the extreme, but also detecting terrorism patterns, detecting fraud patterns. We know that this is being used right now by the government with a high degree of serendipity and a lot of interaction and exploration by analysts. And then on the lower right, this is a very interesting one which already exists. It helps you to build models of what a successful acquisition or merger or investment looks like, and then develop strategies for approaching a company. It comes from customer matrix and has, all of the data curation, but it also has a great deal of serendipity and exploration built into it. And it's process-oriented rather than individual-oriented. So I hope that this makes sense to you. I would love to hear your reactions. And if we can now go to questions, I'm looking forward to these.
Thank you, Sue.
Hi, Sue.
Thank you.
Go ahead.
Yeah, hi, Sue. Yeah, thanks, Diane. Sorry for jumping in too fast. Thanks, Sue. Very, very interesting presentation, and I really am especially interested in your cognitive applications framework. And I have a complementary framework that I've been working on that follows a progression from tool to assistant to collaborator to coach to mediator that you can find in the URL. I put in the chat. There's a URL out to a presentation where you can find that progression. And I think it would be very interesting to get a large number of cognitive applications classified into these different frameworks. So I don't know if you've produced any white papers or anything that, enumerates, 50 or 100 cognitive applications and then tries to classify them. I took the IBM cognitive build. There's over 100 different cognitive applications and classified them into the framework that I've been developing. But yeah, I really like that framework, and would like to follow up with you on this other framework, and so I'll do that via email.
Let's do that, and I will pull in the MIT people who are looking for actual use cases, Jim, because one of the problems is that it's so early that the early adopters, I'm working with a bank, for instance, on fraud applications, and they're experimenting. They've got a lot of POCs out, but not yet a lot of experience, just a lot of, tentative ideas. So in terms of having these deployed, certainly IBM has more than anyone else I know. I'm talking to a number of other vendors, though, and we should be able, especially with MIT's help, to put something together. So let's set up a time. Thank you.
Yeah, great.
Anyone else? Silence.
Go ahead. Press *1 to unmute your line.
Yeah, so if anybody else is listening and has a use case, I would very much like to hear about it, and you see my email on the slide, because I think that there is so much confusion out there. We need to start a dialogue and then give people a framework with which to understand what it is that they're looking for so they don't make very expensive mistakes and also give cognitive computing a bad name.
Can you hear me?
Yes.
My name's Martin Apple, and I'm calling from the West Coast.
Hi.
I'm curious about your use of the word game theory and where you've put it in terms of tools and so forth.
Sure.
Can you explain to me how you're using it? Is this understood to be a system in which you have a large number of players in mathematical game theories like Prisoner's Dilemma and so forth?
Yeah. If you look at the AI Magazine article that came out before the 2011 Jeopardy game, you'll see that game theory was a part of deciding how to play Jeopardy. So in that case, what they're doing is looking at, you've got predictions for how people who are playing the game are going to react to a particular question, what their expertise is. There are a lot of variables. But you can also use this for something like Oncology Advisor because, again, you've got players, the doctor, the patient, the insurance company, the money involved, the risk, et cetera, et cetera. And I believe that those are all amenable to using some form of game theory, even if it isn't what you consider to be a classic game. What do you think?
I don't know. I'm just trying to digest and understand it because I guess I have a very specific way of seeing game theory, and I'm not sure that we're using the term exactly the same way. So that's what I'm trying to understand.
Sure.
But we maybe could take this offline.
Well, sure, I'd love to. And, I'm also thinking of things like the MUC conference and voting algorithms of various kinds as being a part of this. You need a sort of an overarching, if you will, mediator and strategist in there for many of these. So that would be an interesting question. We may want to talk to some of the designers of the original Watson for this.
Okay.
Thank you for the questions, and I can make introductions for Marty and Sue. And I'll also post a discussion on this presentation and this topic on our LinkedIn discussion group, and I encourage other people to ask questions or to please continue the conversation with Sue. And Sue, thank you very much for being our presenter. I think frameworks are really important, and I think this is a really interesting look at cognitive systems. So thank you for being our presenter, and Audience, thank you for joining, and we'll see you next time.
Thank you.
Bye now.